So today I learned about arrays, specifically matrices and data frames. Um, and I felt like I should go over some of the stuff that I left out yesterday. So there's a really useful way to query a function. So like rbind, for instance. Uh, so this will give you um, information about syntax, about what it does, and about the different specifications you can make. Also, Control L will clear your window. And then a really useful way to make a long vector is by going vector1 equals rep 5. Let's do 10. And I forgot a C. The C stands for concatenate, which strings them together. So now we have a row of 5s. Now, let's make a matrice. And the way we do that is by saying matrix1 or whatever variable name you want. And then we make an array of, let's go 1 to 15. And then you have to specify the dimension, which is dim, and then equals C. And then let's go 4 by 4. Now, what this does is makes a 4 by 4 matrix. And since we only had 15 values, all the way, you see all the way up to 15 here, it takes the last value, and because we didn't have anything for it, it recycles the first number. And so if we didn't make this a 4 by 4, but like a 5 by 5, it would recycle the next 5 numbers. So you'd get, you'd get all the way up to 6 in this row. So if you're doing like a really long project and you're kind of mindlessly doing it, not planning it out, it's really important to make sure that you make sure that the vector length that you're putting into your dimension match. And the way to check that is just 4 times 4 is 16, and you only have 15 values. So if you would need 16 here. Okay, so cool. That's really important. And now let's do some cool operations on your matrix. So matrix 1, we can do actually, let's do eigen first. So we can get the eigenvalues very quickly by saying eigen matrix 1. And that'll give you the list of eigenvalues and their respective vectors. So if you ever took a linear algebra, it's really easy. You don't have to do anything by hand. It's a built-in function. You can also do matrix 1 times matrix 1, or any number, I think, and that'll take the first value multiplied by the first value, the second value multiplied by the second value, and so on and so forth. And let's see if we can do times 2 matrix 1. It's multiplied by any old value. Great. And now we see our entire matrix along with all the values have been multiplied by 2. So you can do some really powerful stuff with this. I believe you can also do things like the determinant. You can find it very quickly. So yeah, keep an eye out for that. That's awesome. You can also do that with vectors as well. So vector 1 times 2 will give you our vector 1, which was 5 times 2, which is really useful, very powerful in R. Instead of in Python, you don't have to like filter through all the lists. I believe you can also reference or the index of the vector. So that takes I believe it's the first value. I think R starts on yeah. So R starts on the value 1. And I referenced a null value, basically, I think. All right, so we have covered matrices, we've covered vectors. Let's move on to data frames. So it's called data frame 1, say df1. Let's call data.frame, which is the function to create a data frame. And now let's name our variables. So let's create column 1, say, equals, use an equal sign within the functions. And let's call, I don't know, 1 to 10. Let's do column 2 equals C rep. I want apples. Let's do something more interesting. Flamingos. I want some flamingos up in my function. All right. And then I need 10 of those. I need 10 flamingos. Cool. So now we have a data frame with flamingos, which is a string, and a column of numbers that we created very quickly with that colon there. Now we can reference, let's say, column 1. Oop, I need a cache symbol. Column 1, or yeah, 1. And that'll give me just a vector of numbers. And what's really cool about this is that you can create a new column, say column 3, and define it and say, okay, 21 to 30. That'll give you a new column, column 3, with the values 21 through 30, which is really powerful. I didn't have to, I can just write a new column. I don't have to do anything. I didn't have to reset the default or go back in time to when I created it. I can just add it. And then there are a couple other functions like, let's see, let's do cbind. We can do a vector. We'll say vector 2 is c, 41 to 50. Cool. And so we can do df1 equals cbind. Df1, I believe the data frame goes first and then your vector that you're trying to go in, but we'll see. I forget the exact syntax. It looks like it did it. Yeah. So this is vector 2. It doesn't give you the option to name. I assume somewhere, let's query that actually. Cbind. Let's see if we can actually name that what we want it to be named. Arguments, string as factors, logical. Deparse strings factors. Yeah, no, I don't know if there's an easy way to just write another argument, like if I were up here to say, name equals column 4 or something. We can run that, we'll see. I don't know. Ooh, it looks like it took it. Okay, so it did not really what we wanted. It gave us a name with all of our column 4s. That's actually really curious because this is a vector in and of itself. It looks like it just took this and repeated it automatically to 10, which is actually a very cool thing that I did not know. And it looks like it's cbinding all of these variables. So it's going name equals. So maybe if I had done something like df equals cbind, let's create a vector 3 actually. Vector 3 equals c let's go 61 to 70 this time. Vector 3. I don't know why. I always check it. I always do. I don't know why. Seems like a smart thing to me, but might not be smart to you. So here we go. Let's call df1, we've defined it, we're C binding. Let's say column, what column are we on? We're on column 4, 5, 6, 7. Column 7 equals vector 2, or vector 3. So, let's see, yes, indeed, we can name the column just by saying column 7 equals, which is great. So now we can also reference data in our data frame. Oh, I did not mean to do that. So let's do Control L, which clears the window. Let's go again. Let's see. Excuse me, I would like a little greater than sign, less than sign. So now we can say df1. Let's reference, row 1 to 1, and then let's say this symbol. This symbol, I believe, gives you all of the values for that index. So let's see what happens. Oh, okay, it did not like that. Why? Oh. Interesting. Let's try this. Huh, okay. Maybe just leaving it blank? Yes, leaving it blank gives you row 1. So this is the row index, and it gives you all of that. It's as simple as that. It's really easy. Cool. That's excellent. Now, I want to show you one more trick with matrix. So we have our, let's actually just clear the console again. Thank you, give me my caret. All right, matrix 1. So say I want to reference this diagonal right here. There's a really easy way to do that by using the same method that we did for data frames, and that is to create a new array, array 1, let's call. And we're going to set that equal to C1 through 3 and 3 to 1. And then we will set our dimensions equal to, I believe it's 3, 2. Yes, because this is our row. So we want 3 rows of 2 columns. Oh, I need an equal sign. All right, let's try that out. Oh, why do you not like me? Let's try without the comma there. Let's see. Where's my little thing here? No, it is a comma. It does ask for an... oh, it's because this is not an array. That would do it. We would want an array to be an array. Oh, okay. Yep, I forgot to fix the comma. Classic programming. Oh, series of errors. What is wrong? Unexpected comma. Again. Why? Ah, I didn't use a C again. It's all part of the process, eh? So now we have an array with 3 rows and 2 columns with 1, 2, and 3, 3, 2, and 1. Okay, now, say we want matrix 1 of array 1. That gives us 18 because it's row 1, column 3, and then it's 12 because it's row 2, column 2, and then row 3, column 1. And so we can actually change these values by calling array 1 and then saying define it as, say, 0. So now if we do matrix 1, we get a diagonal of zeros. In the 1 and 3 position, the 2, 2, column 2, and the 3, 1, 3, 1. And that is pretty powerful. And I think that's all I'm going to cover for today. Thank you. Happy learning. Bye.